In this video, we will be talking about Earth's internal heat, how heat is transferred inside the Earth. From earlier lessons, you should remember that as one moves deeper into the Earth, the temperature increases. In the center of the Earth, the temperature can get as high as 6,000 degrees Celsius, that's 10,000 degrees Fahrenheit, and this is hotter than the surface of the Sun. The movement of heat within the Earth is responsible for powering most of the geological processes on Earth, including mantle convection, which we'll talk about in a moment, plate tectonics, mountain building, volcanoes, earthquakes, the formation of ocean basins, the generation of Earth's magnetic field, and much more. The heat inside the Earth comes from two main sources. The first is heat produced by radioactive decay of isotopes in the mantle and crust. Isotopes are different forms of elements that contain the same number of protons but different numbers of neutrons. More on this later. The main thing to know is that these atoms are very unstable, and they tend to want to turn into atoms of different elements. When they do, they release a lot of energy. The second source of heat is heat left over from the formation of the Earth. We call this primordial heat. It is thought that the Earth formed about 4.5 billion years ago, when gravity pulled swirling gas and dust into a clump. The clump grew larger as dust particles, asteroids, and other objects collided into it, and this generated a lot of heat. At first, the Earth was molten, that means melted. The denser materials sank to the center of the Earth, and the less dense materials floated to the top. The planet then cooled. Heat was also released during the formation of the core, when gravitational potential energy converted to heat energy as iron and other dense elements sank to form the core. So, how is the heat from the Earth's core distributed throughout the interior of the Earth? Heat is transferred through Earth primarily through conduction and convection. Different layers transfer heat in slightly different ways. Let's start with the inner core. The inner core is solid and very dense. There's no matter in there that can flow. The inner core transfers heat to the outer core through conduction. The outer core is liquid. Convection is the primary method of heat transfer through the outer core. However, the liquid outer core is much denser than the mantle, and the materials from those two layers don't mix. Hence, the outer core transfers heat to the mantle by conduction. As for the mantle, the lower mantle is heated directly by conduction from the outer core, but the heat is moved through the mantle by convection. The mantle is made of solid rock. It's not made from magma, like some of the pictures would have you think, but extreme temperature and pressure makes the rock in the mantle much less rigid and brittle than the rock in the crust is. We say that the mantle rock is plastic, which means it can deform. But it deforms very, very slowly. We're talking millions of years. The upper part of the mantle is about 200 degrees Celsius, but the lower part of the mantle is about 4,000 degrees Celsius at the boundary between the mantle and outer core. Even though the mantle rock is solid, it behaves like a very viscous, thick liquid. The rock in the mantle that is heated by the core becomes less dense than the rock above it. Slowly, over millions of years, lower mantle material rises through convection. As it does, it cools. At the top of the mantle, the cooler mantle material moves horizontally. Over time, it becomes denser, and it sinks back down. Eventually, the mantle material gets back to the location where the warm material is rising, and a convection current forms. The mantle can also conduct heat, but convection occurs much faster, which is why convection is the predominant method of heat transfer here. As for the crust, because the crust is solid, heat flows through it by conduction. In summary, the movement of heat within the Earth is responsible for powering most of the geological processes on Earth. Most of the heat inside the Earth is produced by radioactive decay of isotopes, or is heat left over from the formation of the Earth. Heat is distributed throughout the Earth by conduction and convection.